A sequence can be regarded as a function whose domain is the set of natural numbers for some subset of it of the type 1, 2, 3 until k. The last term or nth term of an AP is given by L is equal to a plus n minus d, or we can also write an is equal to a plus n minus 1 into d. The sum of n terms of GP is given by Sn is equal to a into 1 minus r power n by 1 minus r. So this is where if the common ratio is less than 1. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today in this session, we are going to study about the sequence series, arithmetic and geometric progression, arithmetic and geometric series, as well as arithmetic and geometric mean. So now let's see what do you mean by the sequence and series. A sequence is nothing but an arrangement of numbers according to some rule. For example, we can take a sequence of even number 2, 4, 6, 8, etc. Sequence of prime numbers 2, 3, 5, 7, 11, etc. So sequence of a multiple of 4, 4, 8, 12, 16, etc. So sequence of tens, 10, 20, 30, etc. So if you see all these numbers, so these are all the numbers of different pattern which is having some rule. If you take this, there is a difference of 2 here. So it's a sequence of a prime number here, but here there are no rule. So when I say sequence, so there may be a property between those two numbers or there may not be. But always it is an arrangement according to some rule. So now let's see the proper definition of a sequence. A sequence can be regarded as a function whose domain is the set of natural numbers for some subset of it of the type 1, 2, 3 until k. It is denoted by a of n or an. So here the domain of the sequence is always a natural number. So it always starts from 1 to the infinity and to the subset of it. So to the subset of means to a very short set of a natural number again. So next is the series. Suppose if we consider a1, a2, a3, an as a sequence, then the sum of all these terms denotes the summation which is called as the series. And the summation of all these terms is given by summation an. So this is called as a sigma, which indicates the summation. So which means the sum of all the sequences. Next is arithmetic progression, that is shortly termed as AP. Now here a sequence A1, A2, AN, etc. So we can have the numbers after AN also, which is an example for an infinite sequence, is called an arithmetic progression if the a term AN plus 1 is given with AN plus D. Means if you want A5 here, so then it is A4 plus some D. So where D is the common difference between those two numbers. So that means A2 minus A1 will be same as A3 minus A1. So that is called as the common difference, and A1 is called as the first term and it is shortly termed as A sometimes. So the general terms of AP is given by A plus D, A plus 2D and the last term as A plus n minus 1 into D, where A is called the first term and D is the common difference, n is the number of terms. The last term or nth term of an AP is given by L is equal to A plus n minus D, or we can also write AN is equal to A plus n minus 1 into D. The sum of all these terms, that means the sum of all the arithmetic sequence is given by a formula Sn is equal to n by 2, 2a plus n minus 1 into D. Next we have the sum of n terms of when first and last term is given. For instance, we have a sequence of a number from 2, 4, 6 until 100. So here we know the first term also and the last term also. Now we need to find the sum of all these numbers. So in such case, we can use this formula, that is n by 2 into a plus 12, provided you should know how many number of terms are present in the given sequence. So therefore here we have Sn is equal to n by 2 a plus L, where a is the first term and L is the last term. The next thing is the arithmetic mean. Now consider two numbers A and B. Arithmetic mean of two numbers is nothing but average between them. So therefore it is equal to sum of those two numbers divided by 2. It is given by A is equal to A plus B by 2. Next is the geometric progression. So geometric progression or geometric sequence of a number is given in such a way that a1, a2, an are the terms of the sequence, means then an plus 1 by an is equal to some r, where r is called as the common ratio. That means if you divide a2 by a1 or with the preceding term a3 by a2 and the last term here an divided by an minus 1, similarly we will get an plus 1 divided by an. So for all of them the ratio or the quotient will be same and it is given by some r. So that r is called as the common ratio, and the terms of a GP are represented by ar square, ar to the power n minus 1 and so on. So here a is the first term, r is the common ratio, n is the number of terms. Now in general, the nth term of a GP or any term of a GP is given by a formula an is equal to a into r to the power n minus 1. Now the sum of n terms of GP is given by Sn is equal to a into 1 minus r power n by 1 minus r. So this is where if the common ratio is less than 1, and if the common ratio is greater than 1, then the formula becomes a into r power n minus 1 divided by r minus 1. So this is the formula to find sum of the terms in GP, and this is the formula to find nth term in GP. The next thing is we have a geometric mean. So geometric mean of any two number is always given by G is equal to square root of AB. So given two numbers A and B, GM of two numbers A and B is G is equal to square root of AB. Now let's find the relationship between arithmetic mean and geometric mean. So here it says that arithmetic mean is always greater than geometric mean. Let's take an example. Now let me take two numbers 2 and 8. So let me take the arithmetic mean of two numbers. So what is the arithmetic mean of these two numbers? 2 plus 8 divided by 2. So arithmetic mean is 10 by 2, which is fine. Now let's take the geometric mean of these two numbers. This is square root of a into b, that is 2 into 8. So which is 16. So which is equal to 4. So we cannot take plus or minus when we are talking about the square root here, because we already defined the sequence is a function where your domain is set of natural number. So therefore we'll take only the positive value. So now clearly you can see here arithmetic mean is having the larger value of the same number with the geometric mean. So therefore this is the relationship between arithmetic mean and geometric mean. Your A is always greater than G. Next. Now we will take some general examples of a sequence and solve the problems. Write the first three terms in each of the following sequence defined by the following. So here they have given some examples of a sequence. We are supposed to find the first three terms here. So we'll start, since n is always should be taken from the set of natural number, we'll take a1. So 2 into 1 plus 5. Next we'll take a2. 2 into 2 plus 5. Next a3. 2 into 3 plus 5. So we'll find the terms here. So 7, 9, 11. So therefore the first three terms are 7, 9 and 11. Next question. An is equal to n minus 3 by 4. So a1 is equal to 1 minus 3 by 4. a2 is equal to 2 minus 3 by 4. a3 is equal to 3 minus 3 by 4. So the values are minus 2 by 4, which is equal to minus 1 by 2. Next we have minus 1 by 4, 0. So therefore the first three terms are minus 1 by 2, minus 1 by 4 and 0. Next we have, what is the 20th term of the sequence defined by an is equal to n plus 1. So the value of n is given as 20. So we need to find out a20. So a20 is equal to 20 divided by 20 plus 1, which is equal to 20 by 21. Next question. Write the first 5 terms of each of the sequence whose nth terms are an is equal to n into n plus 2. So here we can take an value as a1, So then it is 1 into 1 plus 2, 2. So 2. Next take A2. 2 into 2 plus 2, which is 8. Next A3. 3 into 3 plus 2, which is 15. A4. 4 into 4 plus 2, 6. 24. A5. 5 into 5 plus 2, which is equal to 35. So therefore, the first 5 terms are 2, 8, 15, 24 and 35. Next question, an is equal to n by n plus 1. So a1 is equal to 1 by 2. a2 is equal to 2 by 3 because 2 plus 1 is 3. a3 is equal to 3 by 4. a4 is equal to 4 by 5. a5 is equal to 5 by 6. So these are the first 5 terms of the given sequence. Next one, an is equal to minus 1 whole to the power n minus 1 into 5 to the power n plus 1. So a1 is equal to minus 1, 1 minus 1 is 0 into 5 square. a2 is equal to, next we'll take 2 minus 1, 2 minus 1 is 1, 5 cube. Next a3 minus 1 whole square, 5 power 4. a4 minus 1 whole cube. Next we have 5 power 4, 5 power 5. Next a5 minus 1 whole power 4, 5 power 6. So now based on minus here, so the values will be 5 square minus 5 cube, 5 power 4 minus 5 power 5, 5 power 6. So therefore the terms are 5 square minus 5 cube, 5 power 4 minus 5 power 5, 5 power 6. So if you want, you can convert the exponents to the values here. Next, find the indicated terms in each of the following sequence whose nth terms are given by an is equal to 4n minus 3, a17 and a24. So first we will find out a17. a17 is 4 into 17 minus 3, which is 58 minus 3, which is equal to 55. Next we will calculate a24, which is equal to 4 into 24 minus 3, which is 96 minus 3, which is equal to 93. Next question, an is equal to n square divided by 2 power n. We need to find out a7. So a7 is equal to 7 square divided by 2 power 7. So 7 square is 49. 2 power 7 value 128. Next one, write the first 5 terms of the sequences and obtain the corresponding series. So we need to find out the sum of the series which we'll get. So first 5 term, a1 is given, we'll start finding with a2. So if we put a2 is here, 3 into a1. So what is a1? a1 is 3. So 3 into 3, 9. Next we will get a3. a3 is 3 times a2 because if you put 3 minus 1 here, we'll get a2 and a2 value is 9. So 3 into 9, 3 9s are 27. Next a4, 3 into a3. So 3 into 27, which is equal to 81. Next a5, 3 times a4, which is 3 into 81, which is equal to 243. Now we need to find out the sum of all these series, that is summation a1 plus a2 plus a3 plus a4 plus a5. So which is 3 plus 9 plus 27 plus 81 plus 243. So 81 plus 9 is 90, 27 plus 3 is 30, 90 plus 30 is 120. So we are left with 243, so which become 363. Next one, a1 is equal to minus 1, an is equal to an minus 1 by n. So let's take a2 because the first term is given. So a2 means a1 by 1, which is minus 1 by 1 minus 1. a3 A2 by 3 because n we have taken. A2 is minus 1 by 3. Next we take A4. A4 is A3 by 4. So minus 1 by 3 divided by 4, which is equal to minus 1 by 12. Next we have A5. A4 by 5 minus 1 by 12 by 5 minus 1 by 60. Now we need to take the sum of all these numbers. So that is minus 1. A1 is minus 1. A2 is also minus 1. A3 is minus 1 by 3. A4 is minus 1 by 12 and A5 is minus 1 by 60. So taking the LCM and taking minus outside, we'll get 60 here. So we'll get 60 plus 60 plus 20 plus 5 plus 1. So minus 146 divided by 60. So this is equal to 2 7s are 14, 2 3s are 6 divided by 30. So minus 73 divided by 30 is the sum of the given series. So in this session, we have studied some of the sequences which have given a definite formula. So we have found the number of terms and also the sum of the given series. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.